All right, so today we're working on two-way tables. And a two-way table is a table that displays data collected from one source but two categories. So most frequently we're asking one person about two different things. So one category of data is in our rows and one is in the columns. And again, most of these usually have to do with people, and then they're asked two different things. So for our first example, it says the two-way table below shows how many shirts are left at the end of a season, recorded by color and size. Find the marginal frequencies and total to complete the table. So again, this would be 5 people had, or left over at the end of the season, there were 5 small blue and white shirts, 4 medium blue and white shirts. Just a row and a column to figure out how much is left of each. So we do like to total these things up, especially when we're going to then, right now we're talking about marginal frequencies, which are these gray totals. But when we talk about percentages and joint frequencies, it's really helpful to have the total. So here we're simply going to add them up. 5 plus 4 plus 1 plus 2 should give us 12. And then here 9, 14, 16. And then I believe 14, 7, 8, 10, 11, 7, 10, 12. Okay, and then you're going to do the same thing for your columns. So here we have 8, 12, 15, 20, 18, 14, 5, 5, 6, 8. Okay, and then to get your grand total, you just add them all together, but you just want to add either your row or your column. You don't want to do it twice. So I'm going to go ahead and add my column, and we get a grand total of 65. If I add this way, I should also get 65, so I'm going to double check just to make sure that I did it correctly, and I did. Okay, so just adding there. Label examples of joint frequencies, marginal frequencies, and categories. Okay, so a joint frequency is anything in a cell here because it's joining two things, like a small and blue and white. Okay, so this is an example of a joint frequency. Marginal frequencies, so we've done this one. Marginal frequencies are the ones in the margins, anything that's a total. Anything we just filled out. And then categories are your labels. So up here, t-shirt size is a category. All right, example 2. You survey students about whether they are getting a summer job. 75 males respond with 18 of them responding no. 57 females respond with 45 of them responding yes. Organize the results in a two-way table. Include the marginal frequencies. Okay, and again, this part just means we're including the totals. Okay, so just the total. Okay, so we have two different things we're talking about. So whether or not they're getting a summer job or not, so job or no job, and then if they are male or female. Okay, so 75 males respond, so our total males is 75, and 18 of them said no. 57 females respond, with 45 of them responding yes. Okay, so now we should be able to figure out the rest. If I take 75 minus 18, then I have 57 for this cell. If I take 57 minus 45, I get 12 here. And then we can just add down to get these totals. So 57 plus 45 is 102. Then we have 30 and 132. All right, and it's 132 both ways. I was just double checking to make sure it's correct, okay? So this is just a normal frequency. So again, in the cell, that is called a joint frequency. In your totals, that's called a marginal frequency. But we're also going to talk about relative frequency, which is where we take essentially whatever the number is and divide it by the total to turn it into a percentage. And percentages are helpful because it's hard to compare males and females when we didn't poll the same number of people. So when we turn them into relative frequencies, we can compare them easier based on a percentage. It's going to be more fair that way when we're looking for patterns. So example 3, use the data from the table above to show relative frequencies. Conditional relative frequency is the ratio of a joint frequency to the marginal frequency. All right. All right, it does not specify which one we're going to use, so we're going to make this a normal joint relative frequency. So I want you to label it that, joint relative frequency. And then we'll do a conditional down here. So we'll do marginal, where we're focusing marginal, where we're focusing on the columns. Down here, so you can see the difference. Okay, so use data from the table above. So we're using the one from our job, no job. So job, no job, male and female. And all you do is you take whatever is in that cell. Like in this cell, it's 57, and you're going to divide it by the grand total and then times by 100 to get your percentage. So what we're doing is you take, let's write out here, 57 for this first cell over 100 and 32, because that was our grand total, and then times 100. So you're doing that for each piece. So when you do that here, 57 divided 1 by 132 would give you 43.18%. Okay, then for the next one, for no, we had 18 in that cell. So we would do 18 over 132 times 100, which is 13.64. Okay, we're going to do 2 decimal places on these. Okay, then here we had 75 males. So 75 divided by 132 times 100 is 56.82. Or you can still get this one by adding these together. Okay, that's still 56.82%. Okay, so for your females, we had 45 for that cell, would be 34.09%. Then you had 12 in the next one, would be 9.09%. And then you had 57. So 43.18%. Okay, and then for our final row, these should always grand total up to be 100% in this right corner, because you have your 132 over 132. And then 102 divided by 132, 77.27. And then 30 divided by 132, 22.73. And again, you can get these by adding as well. Okay, but the ones in your white section you have to divide out. But then you could add to get your totals if you need to or want to. Okay, so that's just a normal joint relative frequency, which is the one we'll be working with the most. And then here it says use the marginal relative frequency of each column to calculate the conditional relative frequencies. So really here we want all of our columns straight up and down to total 100%. So we're going to use the, and you could do the same thing with a row. So you have to be careful about reading the question. But here we still have job and no job, male and female. Sorry, my pin's behind me today. All right. So again, if we go back to the main table here, instead of using the grand total, we'll use the total underneath. So this time we'll take 57 divided by 102 times 100. So for these, our first example, we're doing 57 over 102 times 100 to get this percentage. Okay? So that would be 55.88. Then here we would take 45 over 102, which gives us 44.12. And then these do add to 100, as they should, but that's an easy way to check. Here, our total was 30, so we'll do 18 over 30 for this cell, which is 60%. And then I know they have to add to 100, so this one's got to be 40. But again, you can take 12 over 30. That should give you 40 also. And then these totals will be the same up here because they're still going over 132. So I'm going to copy them back down. 56.82%, 43.18%. Okay, and those add to 100. All right, example 5. You survey students and find that 40% exercise regularly, 35% eat fruits and vegetables each day, and 52% do not exercise and do not eat fruits and vegetables each day. Is there an association between exercising regularly and eating fruits and vegetables each day? Use the marginal frequency of each row. So we'll make this one our normal, our joint relative. I don't know, what is up with my pen today? Frequency. And then this one we will do our row relative frequency. All right, and this time it looks like we're talking about exercise, and no exercise for each of these. And then whether or not they eat fruit and vegetables or not. So I'm just doing F and B, and then no, F and B. Okay, I know it's kind of hard to read today, but I'm not sure what's up with my tablet. Okay, so you survey students and find that 40% exercise regularly, so that's our total for exercise here. 35 eat fruits and vegetables each day, 35%. And 52 do not do either. So for no exercise and no fruits and vegetables, we have 52 here. Is there an association between exercising regularly and eating fruits and vegetables each day? We're using the marginal relative frequency of each row. So for this normal joint relative frequency, we want our 100% just in the corner. But when we're looking at our row relative frequency, we want 100% across all of our rows. Okay, so all of these should total to be 100. All right, so here if I take 100 minus 35, that should give me 65. 100 minus 40 is 60. So here this would be 8% to total up. This one should be 27. I'm just subtracting. This one should be 13. Okay, to get our row frequency, we're going to take our total, or our cell, divided by the total for that row. So here I would take 27 divided by 35, which is 77.14. 8 over 35 is 22.86. And down here, 13 over 65 is 20%. So this one must be 80% to total 100. And then our bottom row will be the same. We'll have 40 and 60. And these aren't going to add down anymore. They're just going to add across. All right. So is there an association? So we're saying people who exercise and eat fruits and vegetables was 77%. And that's pretty high. And then they don't do either was 80%. So those are pretty close. So I would say yes, there is an association. People who exercise do tend to eat their fruits and vegetables. People who don't exercise also don't tend to eat their fruits and vegetables. So that's why these relative frequencies are helpful, because it doesn't really matter how many people we polled. And if they were uneven, we can look at them based on percentage instead to look for those relationships. All right, so today you're working on pages 22 through 24. That is 3 pages total.